Okay. So here's what we're gonna do. I'm gonna do this. Go live. And I'll give you guys this for right now. Make sure that you can click on my name. Make sure that you can see the video there. I see 6 of you already on that, so that's awesome. So what I think we're gonna do today is we're gonna go through the couple different PowerPoints. I have 3 of them that I'd like to go through today. The 3 I want to go through is the classification of matter. I want to go through physical and chemical properties, and then also development of the atomic model. So you can have that notes package out if that's helpful to you. But a lot of what today will be is just conversations about different topics, how they fit into different things, and what they kind of look like. So we're going to go through this classification of matter PowerPoint first. If I do this, can you guys still see that? Or does it not look like that? What does it look like? Let's see. I'm going to just do this, go live. Ah, yes, it changed. Let's just do this. I don't need this one, I don't think. Maybe I do. Okay, sorry, I'm going to flip around again. I want this, and I want this. Okay. So you can click on that again. Make sure you can get in there, 12 of you. I don't know how many of us are in this chat right now, but 12 looks about right. So in terms of classification of matter, there's an assignment that you get out of this. That's the Lucidchart ones where you get to make a flow chart. You can do that as a piece of paper. You can draw it. You can do it on Lucidcharts. I thought that might be easiest. Just it's something new to try, something fun for you to do. But yeah, the idea is you're going to make a flow chart out of this PowerPoint. So kind of the idea with this is in terms of chemistry, and my degree is a biochemist, so I'm not purely chemistry or purely biology focused. My degree was more focused on looking at the chemistry inside of living things and living organisms. So in terms of chemistry, chemistry is a science concerned with matter that deals with the properties of matter, the changes in matter. So the idea is with my degree, what I wanted to be able to do was I wanted to be able to look at matter and I wanted to be able to say, this is what it is, here's why it is, or this is why something is changing and reacting. And so the kind of idea that we want is we want to be able to take 2 different forms of matter, mash them together, and convert it into something new. Especially in Saskatchewan, that becomes a super valuable point of contention for us with things like potash and uranium mining. Hardest class I ever took was Chemistry 370, and that looked at converting and how potash is actually mined and how uranium is actually mined. Uranium mining is the most confusing thing I've ever learned. That was the first point in my education where I was like, I really don't understand this and I don't get it. So chemistry is not an easy thing. It is quite confusing. Some of you will get it a lot more naturally, and some of you will struggle a lot more with it, and it'll just take more practice is all that means. So in terms of matter, every culture has a slightly different perspective on what matter actually is. First Nations and Métis people, they use the medicine wheel to help them understand. And so the idea with the medicine wheel is that it's organized into 4 different components. So that might be 4 directions, north, south, east, west. It might be 4 seasons, fall, winter, spring, and summer, or it might be 4 colors, as you can see here with the black, white, yellow, and red. And so they try to break things down into 4 different parts so that when they're describing things, there's only 4 constituents that they describe it under. And so another perspective then would have been the Greek philosophers. They believed that there were only 4 quote unquote elements. We now know that there's many, many more elements, but their elements that they described were earth, air, fire, and water. So they were kind of like Avatar, The Last Airbender. They related to those things and described them as such. Depending how big of a nerd you are, you'll understand that reference. In terms of the matter, in terms of the scientific model that we wanted to look at, there was a real lack of understanding of what matter actually was. And they actually did not understand what the smallest parts of chemicals were. I've often thought about what it would be like to go back in time to, let's say, even the time when Jesus was walking the earth, and describe to people either like diseases, how they work, or even just simple chemistry, describing to them like, you're using copper, it's made of these really small things called atoms, which then get made into copper molecules, which then get made into this bigger copper pipe that you're making. I think it would be fascinating to go back and describe those things, or try to describe those things to people that have absolutely no grasp of what you're talking about. So what we learned through the 1800s was we learned that the smallest bit of matter was an atom. And a couple years ago, I think it was a year ago, maybe two, we got the first photograph of an atom. It's a really, really boring picture. It's basically just like a light and then a little circle within the light. It's not the most exciting picture. We've talked about a lot of these things already in our Science 9 review, but matter is defined as anything that has mass and takes up space. And so mass we always measure in kilograms or grams. More commonly, when we are doing chemistry stuff, we're going to use grams, and that will be the common way that we talk about certain chemicals. And then volume is measured in liters, milliliters, or centimeters cubed. Centimeters cubed isn't used very often. That is most typically used for measuring things. If you're in carpentry or construction, that is a more common measurement. If you're in chemistry, centimeters cubed is very rarely used. And then in terms of the states, you probably know of the three main states, solids, liquids, and gases. Plasma is kind of the weird one. It's similar to gases, but very rare. Things that we would describe as plasma would be like fire or would be like lightning. Things that like you don't, it's kind of hard to describe. Like, is fire a gas, a liquid, a solid? Like, where does it fit within that? It moves like a gas, but it also has the properties of a liquid. And so that's where we describe it like plasma. And so what we do then is all of the matter is made up of a bunch of different particles, and those particles will give the things of matter their properties. And so we're going to break it down into a couple different topics now. So the main idea when you're making your flowchart, the main overarching idea is matter. That's the main thing that we want to talk about. That's the main concept that everything else will fall under. In terms of pure substances, those are made of only one kind of particle or one kind of element. So things that would be pure substances that you would be most familiar with would be something like gold. If you have a gold necklace, or if your mom has some gold jewelry, that is a pure element. It's made of one element. As such, pure substances can also be something known as compounds. And as we get further and further into chemistry, we'll learn more about compounds and how they're actually made up. Water is probably the one that most of you are most familiar with. Water being made up of hydrogen and oxygen, and many of you would also know that that's H2O. It's made of 2 parts hydrogen and 1 part oxygen. There's no number beside the little O there, so we say that there was only one of them. And then carbon dioxide, many of you would be familiar with that as well. I remember watching a little video in grade 2 of a little cow that breathed out carbon dioxide and a little tree that absorbed it. I don't know why I still remember that, but I do. And so those are our quote-unquote pure substances. There are 2 subclasses of a pure substance. There's elements and compounds. So those are 2 different things. Then on the other side of the coin, so something totally separate from pure substances, we have mixtures. And mixtures, what those are is those are combinations of pure substances. And there's 3 types of those. So again, mixtures would be another subcategory of matter, so of the main idea, and then that mixtures component is broken down into 3 parts. And the 3 parts that they're broken down into are mechanical mixtures, suspensions, and solutions. Mechanical mixtures, probably the one that you're most familiar with, would be different substances that make up the mixture. Those are visible. And so what is really important for us is actually these prefixes of the words. So you've probably seen the words hetero and homo used in terms of talking about sexuality before. Hetero and homo are also Greek words or Latin words that are used to describe something as the same or something as different. So if something has a prefix of hetero, that means that there are different parts. If something is described as homo, that means they are made of the same parts. So the idea of heterogeneous means that something is made of different parts. So a mechanical mixture, probably the best example of that would be a cookie. A suspension, that would be, these ones tend to be more rare, I think. The particles of one substance are held within the other to create a cloudy mixture. These particles can be separated using a filter, so it is also known as heterogeneous. That one, the picture is the salad dressing. And then the last example there, solutions where they look like one substance. This is called homogeneous, or the same, it looks like it's the same substance. And that one there, the best example of that is the little teacup there, where you have water and then you also have the tea flavoring, but you can't separate them and you can't really tell the difference between them. They look like they're just one solution. And so this is your assignment here, is to create a flowchart that includes the following terms: matter, compound, pure substances, elements, mixtures, solutions, suspensions, heterogeneous mixtures, homogeneous mixtures, and mechanical mixtures. And so there is a right answer for how you're supposed to do the flowchart. You can certainly ask me questions as you're going through it. But yeah, that's your assignment on Lucidcharts there. And that also is the conclusion of our first slideshow. Does anyone have any questions about that first little video there?
So supposed to show all that you just taught us on a chart, a
Yep.
board chart?
Yeah, a flow
Okay.
chart. So the idea with a
Flow
flow chart is, the idea with the flow chart is,
Is that the place that, like, you go to lucidchart.com